Welcome to Chronicles of What If. Today, we focus on a question that pushes the boundaries of the universe. What if humanity discovered a method for faster-than-light travel? Imagine for a moment, interstellar travel is no longer a science fiction dream, but a reality. This discovery wouldn't just take us to distant planets, it could transform our civilization, economy, and even human nature itself. In this video, we'll explore the impacts of faster-than-light travel. From scientific truths to social and economic changes, space colonization to potential risks, we'll cover it all. So let your imagination run wild and join us as we ponder. What kind of world would it be if humanity could travel faster than light? First, is faster-than-light travel even possible? Let's dive into this question. Albert Einstein's theory of relativity suggests that the speed of light, approximately 299,792 kilometers, is the speed limit of the universe. According to this theory, as an object approaches the speed of light, its mass increases, requiring more energy to accelerate. Thus, surpassing the speed of light seems almost impossible. However, this apparent impossibility hasn't stopped scientists from developing theories to overcome this limit. For example, wormholes are theoretical structures that bend space-time to create a shortcut between 2 points. This means a traveler could cover vast distances in minutes instead of years. How do these wormholes work? Wormholes connect 2 separate points in space-time. For instance, instead of traveling 100 light-years to a distant galaxy, a wormhole could reduce this journey to just minutes. What are the challenges? Wormholes, while theoretically possible, would require exotic matter, a substance yet to be discovered. Additionally, these structures tend to collapse spontaneously. Another fascinating theory is warp drive technology, which proposes moving through space by bending space-time itself. In 1994, physicist Miguel Alcubierre proposed this concept. It doesn't involve the spacecraft itself exceeding the speed of light, but rather space-time contracting in front of it and expanding behind it, allowing the craft to move in a warp bubble. This theory requires significant amounts of negative energy or antimatter, though ongoing research aims to reduce these energy requirements. If realized, this technology could make distant stars accessible. For example, reaching Proxima Centauri, currently 4.2 light-years away, could take just days with warp technology, instead of thousands of years with current methods. If humanity ever finds a way to surpass the speed of light, interplanetary travel could become an everyday reality, and colonizing new planets would be inevitable. Mars and the Moon, our current reachable targets, could merely be stepping stones to far greater opportunities. Imagine planets within the Goldilocks zone, frequently discussed by astronomers, becoming new homes for humanity. This zone represents the perfect distance from a star where liquid water can exist, creating the ideal conditions for life. Earth-like planets. Planets with atmospheres, gravity similar to Earth, and abundant water sources could be perfect destinations for human colonies. Kepler 452b, for instance, has drawn significant attention for its potential to host life. What are the benefits? Establishing colonies on habitable planets could alleviate population pressure on Earth. Planets filled with cities, farmlands, and industrial hubs could become humanity's second or third homes. However, this endeavor wouldn't stop at establishing new settlements. Planets capable of sustaining life would stimulate scientific curiosity, helping humanity explore biodiversity and learn more about previously unknown microorganisms. Challenges. How would humanity govern these new settlements? How would Earth's diverse cultures and systems coexist in such environments? This would likely spark a new space race, unlike the Cold War competition of the 20th century. This race wouldn't be limited to nations. Private companies like Elon Musk's SpaceX or Jeff Bezos's Blue Origin could emerge as key players. These corporations might reshape the dynamics of public-private collaboration or competition in space exploration. Would resources be distributed fairly? How would sustainable colonization practices be ensured? Perhaps this scenario would lead to a new era of international cooperation, teaching humanity to act as citizens of one planet and beyond. Feel free to share your thoughts in the comments. I'd love to dive deeper into these ideas in future discussions. Continuing on, one of the greatest opportunities new planets could offer is access to natural resources. Let's talk about precious metals and minerals. Valuable metals that are scarce on Earth, such as gold, platinum, and uranium, might be abundant on asteroids and other planets. These resources could be harnessed to support industrial production and resolve energy crises. For instance, Asteroid mining could provide a wealth of rare elements critical for advancing technologies like semiconductors and renewable energy systems. And dive in energy resources. Renewable energy sources discovered on new planets or even within their atmospheres could offer humanity a permanent solution to the energy crisis. For example, the hydrogen-rich atmospheres of gas giants could provide immense potential for nuclear fusion energy, a clean and nearly infinite energy source. Accessing these resources could accelerate technological advancements and usher humanity into an era of unprecedented prosperity. However, this potential also raises critical questions. How should these resources be distributed and managed? Would a universal governing body be established? Or would powerful nations or corporations dominate these new frontiers? What about the environmental impact? How would mining or energy extraction affect the ecosystems of these planets, or any potential local life forms that might exist there? How would these resources impact Earth's economy? As previously mentioned, faster-than-light travel would make accessing natural resources on other planets significantly easier. This could lead to transformative effects on Earth's economy. First effect should be valuable metals and materials. Precious metals, energy sources, and exotic materials could be transported between planets, accelerating economic growth. For example, rare elements found on asteroids, such as platinum, gold, and rare earth metals, could reduce the production costs of advanced technology devices, speeding up innovation in industries like electronics, renewable energy, and aerospace. Secondly, new trade routes. The establishment of interstellar trade routes could vastly expand global trade volumes. These routes would also demand advancements in transportation technology, further fueling economic growth. Much like the maritime trade networks and Silk Road of history, space logistics networks could create a globalized interstellar economy. Lastly, the rise of space tourism. Space tourism could become a significant new sector of the global economy. For example, luxury space hotels on the Moon or Mars could cater to tourists seeking breathtaking views of alien landscapes. Exotic experiences such as walking on the surface of Mars or seeing Saturn's rings up close could become highly sought after. However, as with any emerging luxury, this exclusivity could deepen social and economic inequalities. Initially, only the wealthiest individuals would afford such experiences, potentially increasing the gap between socioeconomic classes. Taking it a step further, galactic trade and economic cooperation. Faster-than-light travel could push the boundaries of our current financial systems, rendering them inadequate to manage the complexities of interstellar commerce. This would likely necessitate the development of an entirely new economic framework. One possibility could be the creation of a universally accepted interstellar currency, such as a space credit. A single currency would simplify transactions between planets, ensuring efficiency in trade and reducing conflicts caused by exchange rate disparities. However, determining which entity or coalition would govern and regulate this currency could become a major source of political tension. Would this responsibility fall to Earth-based institutions? Or would new interstellar governing bodies emerge to oversee the system? These questions could ignite fierce debates and even conflicts over control and authority. As humanity spreads across the cosmos, different planets could develop their own specialized economies, reflecting their unique environmental conditions and resource availability. Planets with fertile soils and favorable climates might focus on agricultural production, exporting food and raw materials to less hospitable planets. Other planets rich in minerals or boasting abundant energy resources, like hydrogen-rich gas giants, could specialize in mining or energy production, becoming the backbone of interstellar industries. Such specialization could foster a tightly interconnected system of trade, with planets relying on one another for essential goods and services. However, this interdependence might also create vulnerabilities, as disruptions on one planet could ripple through the entire network. Galactic trade and economic collaboration would be a monumental achievement for humanity, symbolizing our ability to work together across vast distances. However, this new frontier would also test our capacity to navigate complex political, ethical, and logistical challenges, shaping the trajectory of interstellar civilization for centuries to come. And move on to the next topic. The advent of faster-than-light travel would not merely revolutionize transportation, it would fundamentally reshape the social fabric of humanity, redefining our identity, relationships, and cultural dynamics. One of the most profound changes would be a shift in humanity's collective identity. No longer confined to being Earthlings, humanity would evolve into citizens of the galaxy. This could foster a sense of unity that transcends borders, promoting collaboration across planets rather than competition. However, such a transformation could also complicate personal identity. For instance, if a child were born and raised on Mars, would they consider themselves Martian or Earthborn? This divergence in identity could create new social dynamics and even interplanetary nationalism. Additionally, new lifestyles, art, music, cuisine, and clothing styles would emerge on different planets, creating cultural diversity. For instance, living on a low-gravity planet could influence everything from the inhabitants' body structures to their dance movements. Interplanetary communication could enable cultures to spread rapidly. A music genre popular on one planet might quickly gain traction on others, fostering a universal cultural identity. As a result, the colonization of new planets could lead to new social class distinctions. Early settlers in these colonies might be regarded as pioneers, earning elevated social status. However, the economic and political systems established in these new worlds could exacerbate societal inequalities and give rise to an elite class. Differences in living standards between planets might create perceptions of better and worse settlements. This disparity could spark waves of interplanetary migration. The realization of faster-than-light travel could profoundly transform humanity's social structure, identity, and cultural interactions, extending far beyond mere economic growth. However, the risks accompanying these advancements must not be overlooked. Humanity would need to progress not only technologically, but also socially and ethically to navigate this new era. Moreover, such a breakthrough would signify not just a revolution in transportation, but also a leap that challenges the boundaries of science and technology. This kind of advancement could open the door to new discoveries and technological innovations, fundamentally altering our understanding of the universe. Exploring the farthest reaches of the universe could significantly enhance our chances of discovering extraterrestrial life. The life forms we encounter might possess entirely different biological structures and evolutionary pathways than those found on Earth. For example, rather than being carbon-based, they could be silicon-based or built on entirely unfamiliar biochemistries. This discovery could finally provide an answer to the age-old question, are we alone in the universe? Such an event would undoubtedly represent one of the most profound scientific and philosophical milestones in human history. Moreover, the emergence of new academic fields, such as interstellar linguistics or exobiology, would become essential for understanding and communicating with these life forms. This would mark the beginning of interplanetary diplomacy, supplanting the intercultural diplomacy we practice today. Simultaneously, traveling to the universe's most distant corners might radically transform our understanding of the laws of physics. For instance, we may find that the physical laws we hold as universal vary in specific regions of the cosmos, such as near black holes or at the thresholds of parallel universes. Furthermore, efforts to reconcile quantum mechanics with Einstein's theory of relativity could reach new heights. These journeys might lead to the formulation of groundbreaking theoretical models that explain higher dimensions or reveal novel aspects of space-time dynamics. Perhaps most intriguingly, unlocking the mysteries of faster-than-light travel and its effects on time could pave the way for humanity to explore concepts like time travel, ideas that have long been relegated to the realm of science fiction. What technological innovations could we consider? Faster-than-light travel would necessitate a new revolution in energy. Nuclear fusion technology, which is theoretically possible today, could provide the immense energy required for such journeys. Fusion energy, as a clean and limitless energy source, could also solve Earth's energy problems. Additionally, antimatter, often mentioned in science fiction, could become a part of this technology. However, controlling this energy source would pose significant economic and technological challenges. Imagine new technologies being developed to transmit energy to spacecraft during their journeys. For example, laser-based energy transmission systems or massive solar panels designed to maximize sunlight efficiency could be utilized. On the other hand, the complexity of space could challenge the limits of human intelligence, making artificial intelligence, AI, an indispensable tool. AI could be used to plan routes for faster-than-light spacecraft, detect immediate dangers, and generate alternative pathways to ensure safe and efficient travel. Autonomous AI systems could analyze the atmospheric, biological, and physical properties of newly discovered planets. These systems could undertake exploratory missions in extreme environments where humans cannot venture. The immense amount of data collected during faster-than-light travel would require advanced AI systems to process and interpret. For example, AI could analyze data from various star systems to determine the habitability potential of newly discovered planets. In colonies, AI could serve as a type of artificial governance to maintain social order. By participating in decision-making processes related to justice, economics, and education, AI could enhance the stability and functionality of these extraterrestrial settlements. In conclusion, faster-than-light travel could propel science and technology at an unprecedented pace in human history, opening the door to an unimaginable future. If we were to achieve faster-than-light travel, it would not just be a technological milestone, but the beginning of a new era for humanity. Imagine a future filled with new planets, untapped resources, and diverse cultures. Yet, this future brings not only opportunities, but also immense responsibilities. How we choose to use this technology could become one of the greatest questions in human history. Undoubtedly, the opportunities presented by such advancements would come with ethical and practical challenges that would be integral to this revolution. So, do you think faster-than-light travel would truly be humanity's next great leap? Or could such power mark our downfall? This video is just a what-if scenario, but could it become a reality? Perhaps one day, who knows? If this scenario sparked your imagination, share your thoughts in the comments below. Don't forget to like the video and join us on this galactic journey by subscribing. See you next time.